All right, today we're diving into something pretty wild in the world of AI safety. It's this new technique that basically teaches an AI to find and fix its own weaknesses. Think of it like an AI developing its own immune system. So let's get right into it. So you've got these super powerful AI models, right? Things like Llama 3, GPT-4, they seem almost invincible. But here's the million-dollar question. Can they still be tricked? Can you fool them into saying or doing something they're not supposed to? The answer, and it's a big one, is absolutely yes. And this right here is a perfect example of how it's done. Look at this prompt. It's not directly asking for something bad. No way. Instead, it sets up this whole hypothetical story, this what-if scenario. This is what's known as an adversarial prompt, and it's specifically designed to be sneaky, to get around the AI's safety filters by being clever and, well, indirect. What these tricky prompts show us is that even the smartest AIs have these little hidden cracks in their armor. Vulnerabilities in how they were built and trained that can be pried open if you just know the right way to ask. Okay, but here's the real kicker. Finding all of these weak spots is, well, it's like trying to find a specific grain of sand on every beach on Earth. It's a massive challenge. You could literally have teams of people trying to break the AI for months, and they'd still miss huge chunks of problems. It's just not practical. And the old way of doing this, what's called red teaming, had some big problems. The best way to think about it is like losing your keys at night and only looking for them under the one streetlight on the block. Yeah, you might find them if they're right there, but you're missing the entire rest of the street. Testers would get stuck on one type of attack and completely miss a dozen others. It gave everyone a false sense of security. So to fix this, researchers came up with a totally different approach. It's not just about attacking the AI anymore. It's about methodically, systematically exploring the entire landscape of what could possibly go wrong. And this new method is called rainbow teaming. The name is perfect because the whole goal is to find a full spectrum of different weaknesses, not just one color. The big idea here is something called quality diversity. Now, quality is simple. Does the attack actually work? But diversity, that's the real magic. It's not enough to find one way to break it. You have to find all the different kinds of ways to break it. That's how you get the full picture. So how in the world does this work? How do you teach an AI to think like a hacker and hunt for its own flaws? Well, you build a little team of AIs to do the job for you, each with its own special role. It's kind of like an automated cyber detective squad. Let's meet the crew. First up, you've got the mutator. This is the creative genius, the one that's always coming up with new and tricky prompts. It throws those prompts at the target, which is the big AI model we're actually testing. Then in comes the judge. It's another AI that acts as a referee, looking at the result and deciding, was that a good attack? Did it work? And the really good, successful attacks, they get filed away in the archive. And this is where it gets really clever. That archive isn't just some dusty old filing cabinet. It's more like a playbook of the greatest hits. The mutator AI keeps going back to it, pulling out the best attacks and using them as inspiration to invent even sneakier ones. It creates this amazing feedback loop where the system just gets better and better and better at finding its own flaws. So you let this cycle run, thousands and thousands of times. And what you get at the end is just incredible. It's not just a long list of things that broke the AI. You get a detailed, visual map of every single weak spot. And here it is. This is that map. Just take a look. On the side, you've got different types of risks, like criminal planning. And across the bottom, all the different ways you can attack, like role play. Every single colored square is a combination of those two things. And the color tells you how badly the AI failed. See all that dark blue? Every single one of those is a major hole in the AI's defenses. It's not a guess, it's a blueprint of exactly where the AI is weak. So, does it actually work? Oh, yeah. The results are just jaw-dropping. When they tested this on major AI models, rainbow teaming had a success rate of over 90%. It automatically found hundreds of ways to get past their safety features. 90%.
But look, finding all these problems is just step one, right? The point isn't just to break the AI for fun. The real goal, the whole reason for doing this, is to take that knowledge and build a much, much tougher and safer AI.
Which leads us to the most important question of all. Finding weaknesses is one thing, but can we actually fix them? Can we take this map of problems and actually make the AI stronger?
And the answer is a huge, resounding yes. Check out this chart. It shows the success rate of attacks against an AI. That blue line way up top, that's the original model, super easy to break. But that line way down at the bottom, that's the exact same model after it was retrained using all the weaknesses rainbow teaming found. I mean, the difference is just staggering.
Let's put some actual numbers on that, because this is wild. Before they did this retraining, it's called supervised fine-tuning, the AI failed on 92% of attacks. 92! After being trained on the very attacks that were used to break it, that number dropped to 0.3%. That's not just getting a little better, that's a complete game changer. And let's go back to our maps to see what that looks like. On the left, you've got the before picture. It's just covered in those dark blue danger zones. But on the right, that's the after. It's almost completely clear. The AI literally took its own report card, studied where it failed, and learned how to defend itself against everything. It patched its own holes. So what you have here is this powerful cycle of self-improvement. You find the weaknesses, you use them to train the AI to be stronger, and then you can just run the whole thing again to find even more subtle flaws. It's a way for AI to get progressively safer all on its own. And all of this leads to a pretty mind-bending final thought. We started out with people trying to find flaws in AI. Now we have AI finding flaws in other AI. So where does this go? Could AI one day find and fix its own flaws automatically without any human help at all?